Alright, hello everybody, welcome back. We are live today on this beautiful Sunday, February 2nd, 2025, teaching ourselves some computer science. We are going to be back jumping into Harvard CS50X 2025 Week 4 on memory. We are currently on the Week 4 problem set, where we have completed so far the volume and the filter less problems from this week's problem set. So we got two more problems. We have a filter more and I believe a recovery problem. So we are almost done with this problem set. So hopefully we can wrap it up this stream and then maybe take into a shift into some other things and start moving on. Hello everybody. Hello Mahan. How's it going? Welcome in. Welcome. How's it going? How we doing out there? Okay. Let's get into here. Week 4 problem set. Okay. Let's do this one here. Okay, so perhaps the simplest way to represent an image is with a grid of pixels, dots, each with a different color for black and white images. Thus, we need 1 bit per pixel, as 0 could represent black and 1 could represent white, as in the below. In this sense, there is an image this is an image just a bitmap, a map of bits. For a more colorful image, you simply need more bits per pixel. A file format like BMP, JPEG, and PNG that support 24-bit color use 24 bits per pixel. BMP actually supports 1, 4, 8, 16, 24, and 32-bit color. A 24-bit BMP uses 8 bits to signify the amount of red in a pixel's color, 8 bits to signify the amount of green in a pixel's color, and 8 bits to signify the amount of blue in a pixel's color. If you've ever heard of the RGB color, well, there you have it, red, green, blue. If the RGB values of some pixel in a BMP are, say, 0xFF, 0x00, and 0x00 in a hexadecimal, that pixel is purely red, as in 0xFF, otherwise known as 255 in decimal, implies a lot of red, while 0x00 and 0x00 implies no green and no blue, respectively. In this problem, you'll manipulate these RGB values of the individual pixels, ultimately creating your very own image filters. In a file called helpers.c and a folder called filter more, write a program to apply the filters to BMPs. All right, so we're diving right down in here into the filter more problem. Okay. So we need the distribution code here. Oh, we'll have to get rid of this actually. Studying for my math test on Thursday. Well, good luck to you, Mahan. I really hope you do well on the math test. What class is it for? What math class are you learning and how are you enjoying it? Hey, Helpful Lamb, how's it going? Welcome in. It's awesome to hear from you. How you doing? What are you studying this afternoon or this evening? And what brings you in? How you doing? Welcome, Helpful Lamb. Hey, Tim, welcome back. How's it going? Hope you're doing well and hope everything's good for you. What you working on tonight, Tim? What are we working on tonight, everybody? Okay, here we go. All right. So, I mean, does this problem, the only thing that's different is our grayscale the exact same? Blur. We'll talk about the image, for example. Place the image in front of a mirror, any pixel left side image on the right side, vice versa. Okay, so it looks like the problems are pretty similar except for just the last one. So I think we can probably just, uh, you know, bring in our. Ooh, So let's go to helpers.c here. This one doesn't have a sepia, it has this other one. So I'm going to take my grayscale function, copy this into filter more, like so. Go to filter less, helper C here. Go to reflect. We'll take this whole thing, filter more into reflect. Filtered less, we'll take our blur that we did yesterday. Oh, hello everybody. So I forgot to mention that I finished the blur problem yesterday. So if you remember correctly in our last stream yesterday, I ended the stream by, because I had to go to actually a movie. I was seeing a movie with my girlfriend. We went and saw Companion. It was really good. It was about kind of a autonomous companions in the future and like what happens when they go rogue if you were to like mod one or something like that. So it was really, really interesting. And it was kind of like, has that trope of a lot of movies have done of like that whole autonomous companion stuff. But it kind of like a unique perspective on it, and it wasn't corny at all, which was really good. It was actually a pretty good film, so I highly recommend that one. But when I came back from the movie yesterday, I sat down. I wanted to sit down for like 10 minutes to see if I could try to solve it, and we actually were able to yesterday. So some things that we had to do. So we left off yesterday on right like on here. So I had this exact code just on the outside of the loop because I was trying to handle the edge case. So rather than handling the edge case trying to pass, I just put this in the loop and inverted these statements to basically say, okay, when we want to actually do it, let's go ahead and do it. Else, let's just keep moving on in the iteration. So now that's being taken place. I added a count variable here, right? The count variable, because we need to know what to actually divide by to count if we perform these, you know, these edge cases or whatnot, so we can actually determine, what to divide by to take an average of, or the amount of numbers to average. So the count is keeping track of that total number to average by. And then I casted these to floats rather than integers, so I could round them and have integers be brought into average red, keeping the value CS50 wanted, and then I just saved at each I iteration, j and I iteration those values. Yeah, so that was this one here. Cool. All right. And yeah, and then this one solved that problem. So we just moved this inside of this case to handle it. I had to change these if statements slightly to mean the inverse, and then we just added this count and then changed the float things around, and that solved the problem. So that was this blur function here. So let's go ahead and grab it, and then let's take it in here. Or whoops. And let's put it into here, like so. Okay, so now we're on this edges one here. So the edges function is the only one that's different for this problem. So this one says, in artificial intelligence algorithms for image processing, it is often useful to detect edges in an image, lines in that image that create a boundary between one object and another. One way to achieve this effect is by applying the Sobel operator to the image. Like the image blurring, edge detection also works by taking each pixel and modifying its base on the 3x3 grid of pixels that surround that pixel. But instead of just taking the average of the 9 pixels, the Sobel operation computes the new value for each pixel by taking a weighted sum of the values for the surrounding pixels. And since edges between objects could take place in both a vertical and horizontal direction, you'll actually compute two weighted sums, one for detecting edges in the x direction and one for detecting edges in the y direction. In particular, you'll use the following two kernels, where g of y, -1, 0, 1, negative 2, 0, 2, negative 1, 0, 1. So how to interpret these kernels? In short, for each of the three color values for each pixel, we'll compute two values, gx and gy. To compute gx, for the red channel, the value of a pixel, for instance, will take the original red values for the 9 pixels that form the 3 by 3 box around the pixel and multiply them each by the corresponding values of the gx kernel, and then take the sum of the resulting values. Why these particular values for the kernel? In the gx direction, for instance, we're multiplying the pixels to the right of the target pixel by a positive number and multiplying the pixels to the left of the target pixel by a negative number. Yeah, because of the target pixels in the middle here, everything to the left is negative, to the right is positive, and vice versa. Top is negative, bottom is positive for the y. When we take the sum of the pixels on the... Okay, so when we take the sum, if the pixels on the right are a similar color to the pixels on the left, the results will be close to 0. The numbers cancel out, but if the pixels on the right are very different from the pixels on the left, then the resulting value will be very positive or very negative, indicating a change in color that likely is the result of a boundary between objects. And a similar argument holds true that for calculating edges in the y direction. Using these kernels, we can generate a gx and gy value for each of the red, green, and blue channels for a pixel, but each channel can only take one value, not two, so we need some way to combine gx and gy into a single value. The Sobel filter algorithm combines gx and gy into a final value by calculating the square root of gx squared plus gx squared, and since channel values can only take it on integer values of 0 to 255, be sure the resulting value is rounded to the nearest integer and capped at 255. And what about handling pixels at the edge or the corners of the image? There are many ways to handle pixels at the edge, but for the purpose of the problem, we'll ask you to treat the image as if there was one pixel. We'll ask you to treat the image as if there was a 1 pixel solid black border around the edge of the image. Therefore, trying to access a pixel past the edge of the image should be treated as a solid black pixel, values of 0 for each of the red, green, and blue. This will effectively ignore those pixels for our calculations of gx and gy. Specification. Implement the functions in helper C of these functions. Okay. Cool. Interesting. Okay. Hey Justin, how's it going? Tim, do the Christmas lights stay up year round? Yeah, they do. Yeah, just leave them up there. They're fun up there. Mahan, calc with proofs, we are doing integrals. I never studied it before in high school or self-study. Awesome. Well, it sounds like you're having a great time with that then. Yeah, we're still waiting for 1.2K subs. Hopefully today we can hit it this stream. So if you're watching here, you might be the lucky 1,200th subscriber onto the channel. We've been growing quite, rapidly over the course of the few weeks. So thanks so much for everybody for supporting and for joining the community. It's really awesome that we have everybody here, night in, night out, supporting each other and studying. So here we go for edges. So for edges, right, we obviously need to iterate over all the values so for int I equals 0, while I is less than the height, here I will continually increase, right, and then for int j equals 0, while j is less than the width of this 2D array, j will increase each iteration. Okay, and then we have a 3x3 grid here again that we're going to do. So similar to before, So in this problem, we are doing edge detection for this one rather than doing blur. So for edges, we need to, so the kernels will compute two values. For each of the color values in the pixel, will compute two values, gx and gy. To compute gx for the red channel, the values of the pixels, for instance, will take the original red values for the 9 pixels that form. Okay, so we need to compute this gx and gy variable at each point within here. So we're no longer computing, or we're gathering the red so we're taking a copy first. So let's keep our copy, all right? Right. Hey Wing Hong, how's it going? Welcome in. How's it going? Hey Ryan, welcome back. Have you completed this one, Ryan? Okay. All right. Ryan's completed this one. Awesome. Wing Hong says he's surviving. Hey Yasir, welcome. Chase from space. Awesome that you're able to hop in here. How's it going? Welcome back, man. Been a couple of weeks. How's it doing? How's it going? Okay, so we're making a copy. We are then iterating over I and j. Hey, Jamian, welcome. Hopefully I pronounced that correctly. Please tell me if I did not. Hopefully I can get it right for you. So I'm not really understanding the problem here. Like, what is these kernels? You know, in the both directions. So how to compute in the short for each of these three color values? For each of the three color values for each pixel. Okay, so we're accessing each pixel here, right? Um, so if we go back to our blur, we're copying our thing. We're going into our copy and accessing each pixel. We are accessing, we're making a subarray or submatrix of values, a 3x3 submatrix. And then we're taking the value of the pixel at this submatrix and computing something for it and doing count, okay? So then for each pixel, we'll compute two values of gx and gy to compute gx for this channel. For the red channel, for instance, we'll take the original red values for the 9 pixels that form a 3x3 box around the pixel, multiply them each by the corresponding values in the gx kernel. So you multiply each of the red values. So this right here, red, so this will be float gx red. What is being computed here? We'll take the original red values for the 9 pixels that form a 3 by 3 box. So right here where we're accessing those red values, if they're within our bounds, and we'll multiply them by each of these values here. So let me say, can we put out front here a couple of variables, like an array of gx. So int gx nums is equal to, or gx array of 9 equal to, how do you declare all the values? Like this, -1, 0, 1. Well, we're going to be on the red pixel here. We need to multiply the pixel that's right here by this value, -1. The pixel by here is 0. So that's what it's doing here. This is interesting. So we need to have these numbers be either saved somewhere or dynamically happen or whatever within the loop. So if we say, well, our I is negative, a row is -1 here, up to 1. So here's our conditions where they meet. So we basically need to have some more if statements within here that to capture whether it's at one of these positions and say, okay, if it is, you need to multiply it by this value. So how can we determine that? Well, if the row is -1 and the column is -1, for in column -1. So we're going to access so let's go if column is equal to -1 and row equal to -1, which means we're back here. So column, so this is the 0 column, this is the 1 column. -1, -1. So if column, if column -1 and row -1 were in this position, we want to multiply the value of red, blue, and green by -1. But then what are we saving that as? So why these particular values, we're multiplying them. When we take the sum, We can generate a value of gx and gy for each of the red, green, and blue value channels for a pixel. To compute gx for the red channel, for instance, we'll take the original red values from the 9 pixels that form a 3x3 box around the pixel, multiply each of them by the corresponding value in the g of x kernel, and take the sum of the resulting values. So we are summing g of x. Okay, so we'll go here and say red gx red we have gx green and then we have gx blue. Wing Hong says he survived and he's had a rough morning. Sorry to hear about that, Wing Hong. Hope you're feeling better. Okay, so we have gx red, gx green, gx blue here, which are floats. And so we are going to calculate the gx red at each pixel plus equals this right, times -1.0. So we're going to multiply the red value by -1. If the column is equal to -1, so if the column is equal to -1 and the row is equal to -1, we'll do that. Because if you're in here, okay, so then I think, right, so if the column is -1 and the row is -1, we are going to perform this operation here. Right? Where you have gx blue, gx green, and gx red are all going to be multiplied by -1. Okay. So then I mean, we could say another loop here, right? And say for because column is technically -1 and goes to 0, but we have a 2 here, which throws things off. So you don't ever, I never gets up to 2 because -1, 0, and 1 to create the 3x3. So then can we say can we just use a loop then and just do no, because the thing is you go from -1 to 0 to 1. -2, 0 to 2, and then back down. So if it kept going up, then yeah, we probably could, but you go back down. Am I even on the right track here? I don't even know. So let's say row is -1, column is negative. So let's say that we're on in our algorithm the pixel of, let me get my whiteboard. Let's say that we have a photo here and we're on this pixel right here, which is at um, height of what, like 2 2 2, I guess. Okay, so in this case, we're at this pixel 2 2. So j and I is 2. J is less than I plus plus. This is our sub matrix. This is our sub matrix. Right, so we're worrying about I and j, less than the height, less than the width. So in this case, we're at 2 2. So what happens here? Row's -1. We're going to access the picture at row, or at the I, which is -1. -1, -1, plus 2, so 1 1. So we're going to access this pixel up here, 1 1. In this case, because this statement did pass, if we're at, yeah, which is that case, we're going to multiply it by 1. And then that's it for that pixel. We're going to move on. So else if the column is equal to -1 and the row goes up to 0. So what happens if column, hey Sam, how's it going? Welcome in, Sam. So then what we need to say, so if the column is -1 for height, because column, no, j is associated with the column. So let's do the row first, because that's what we're dealing with first. So row is with I, so row equal to -1, column hey Lo, how's it going? Did we make it, Tim? 1.2K. Thank you guys so much for the support. Honestly, you guys are really awesome. I say it day in and day out, but I truly, truly mean it. It takes a lot of effort and energy to come and sit here every day, and hold yourself accountable, and make and study something like this. It's a lot easier to go along with the norm of society and just watch TV, play video games, go out, hang out with friends, whatever. But by taking this time, committing and working on ourselves mentally and within our own education, we can hopefully see some rewards later on in the future with this personal investment. And I only wish that on you guys as well. I believe that that this will work out for us. If we just think about it hard enough, believe in it long enough, manifest it, we can make this goal of ours come true. Just learning this material as best as we can. And yeah, so thank you guys so much for being here. So if the column, so if the row in this case is -1, If the row in this case is -1, I'm getting mixed up with this column row crap in J and I. Now that's where stuff is starting to go fuzzy here. So remember, I is dealing with our height, and J is dealing with our width. So when we say for row and column, and row is with our height and columns are with our width, okay? Perfect. So if the row is in the -1, if this is our 0 row, technically the one that we're on, if the row is -1, but our column is 0, 0, right? What are we going to do? We're going to do this same thing here, but multiply this value by 0. So I mean, I feel like we're going to have a bunch of if, else, if statements here. Is that the right way to go about this? It's going to get really big here. I don't know. So if the row at -1, column -1, multiplied by -1, 0, column at 1. So this one is just going to add 0 every single time. So you don't really even need to do anything here. Okay, so we don't even need to handle a case here. So -1 and 1 will multiply this by just added it by itself. Like so, right? You can use guard statements instead of nesting a bunch of if statements. What do you mean guard statements? Can you clarify? Like Boolean expressions? Like, I'm not sure. Right, so we skip over that. So now we need to handle this middle case. Okay, so if actually, because this is mirrored down here, we can handle this case in here. So if one row is equal to this, or row equal to this is -1, 1, -1, 0, 1. Row is equal to 1, and column is equal to -1. So if row Okay, so if the row is equal to -1 or 1 and the column is equal to -1, right, do this, which means that you're going to be here or here. So -1 column, row is 1 or -1. Else if row is equal to -1 and column is equal to 1 or negative 1. Negative, no, this is the negative first row, 0 row, first row. So row, like if this thing isn't true, continue. Okay. Where would you suggest that we utilize those at here? So if the row is equal to negative 1 or 1, negative 1 or 1, so then if it's the row is equal to negative 1 or 1 and the column is equal to 1, yeah, so this expression up here, but we'll say column is 1. Right. So then we need to handle this last case. So the thing is though is we also need to include GYs here. Right? As well. And then we can compute these at this stage as well. We don't need individual statements for the GY because we're already at this place. So we can compute GY at this point as well. Now, I appreciate you, Lo. What do you, first two if statements. So are you talking about these two if statements or are you talking about these two if statements here? So let's just handle the GX ones for now. Let's just handle this. So else if this, right? Else if, okay, the row is equal to 1 and the column is equal to okay, so I have two else if statements. So else if the row is equal to 1 and the column is equal to negative 1, right? We're going to take these values and multiply them by negative 2. I must be doing something right if Mahan isn't correcting me here. I must be on the right track, because usually when I start getting off the on the wrong path, he starts chiming in fast. So we might be. Hopefully we're on the right track here. I'm not sure though. Okay, let's keep going. Let us know for sure. So at this point in time, we can copy this down, change this to dy, 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 And actually nothing happens, that gets multiplied by 0, so actually nothing happens here for dy. So if we're at negative 1, 1, if rho is at negative 1 or 1, and column is at negative 1, so these two positions here, the top and bottom left corners, we're going to multiply by 1, negative 1 here for dx. And then dy, we'll have another nested if statement, I guess. If so we're at these two spots. Rho is equal to negative 1 and column is equal to negative 1. Do this, but for dy, right? Else well, no, we just need to say else, right? Meaning that the column in this case would be 1. So you'd multiply by, or the row would be by 1, sorry. Because the row is the one that can change. The column is not going to change from negative 1 for dy. So this is getting really confusing. Negative 1, negative 1, negative 1, 1, negative 1. So if rho is equal to 1, so else then rho is equal to 1, we're going to set these values here by just themselves, by 1. So we'll just say this here. Okay. So that handles this square, this square, this square, and this square. Else if the row is negative 1 and the row is 1 and the column is 1. So over here. So these two positions, the right and left corner. So if it is, dx goes here, multiplies by 1. So we have then if rho equals negative 1, right? Column never changes here, so we don't even need that statement. If rho is equal to negative 1, so if rho is equal to negative 1 in this case, in this case, right, so if rho is negative 1 or 1 and column is 1, so the two right cases, 1, 1, we'll multiply the gx by 1. Else if rho is negative 1 for this value, multiply by negative 1 for gy. Here, these guys. Else right? gy is going to be multiplied by 1, this guy here. The same format as above, because it's -1. Rho is equal to -1. These if statements are getting confusing. So in this point, we're dealing with these two left ones and these two left ones. So no matter what, gx gets multiplied by -1 here, right? But if rho is -1, this one up here, we multiply gy by -1, else it's this one here, rho is 1. So in this case, it's the same exact thing. It's the same exact thing then, right? Because those numbers are -1, -1, 1, 1, same thing. Like that. Okay. So else if we are in these middle case here, this is getting crazy. Else if we're in the middle case where we're at -2, or column, sorry, rows is 1 for this middle row. Or columns is 2. Or columns is equal to 1, sorry. So this guy here, row is equal to 1. Column will equal to oh wait, I'm getting confused. Oh boy, getting confusing here. Okay, I gotta keep these in track here. So we're dealing with, let's just handle the g of x ones for right now. So if the row is 1 and the column is -1 or 1, okay, keep going here. Don't give up. Don't give up, we got this. So if the row is 1, the middle row, and the column is -1, we multiply by -2. And do nothing for dx. But if the column is 1, we multiply by +2. So say if column equals to -1, do the following. Right? Else multiply this by 2, because column would be 1, and we multiply on the other side, which is still 0 for dx, for gy I mean. So then what happens if column is, sorry, this is row is 0. Right, my bad. Row 0. So I say else if it's getting really long here. Right, the row is 0 is -1, I'm sorry, or row equals to 1, right? And the column is equal to 0. Right? I need these green ones here. So in this case, if we're at row -1 or 1 in column 0, so the middle rows, the middle column I mean, we're only going to mess with if row equals -1, then gy gets multiplied by 2. Gy else gy gets multiplied by -2. Okay, so I believe at this point we're handling all of our cases. Now let's go through and check these. This might be annoying, but we did a lot there. So if the row is equal to -1 or 1, so -1 or 1, so the top or bottom row, and the column is equal to -1, so this position, this position, this position, or this position, the top left ones, right? If row is equal to -1, we're going to multiply. We're going to do all of this right here, like that, right? Like so. Okay. Else, row is equal to 1. In this case, so column is still -1, row is equal to 1, so we're dealing with this one and this one. No, column is still -1, so row is equal to 1. So this one here, we're multiplying gx by -1 and gy by 1. So we need to take these values here still. And I guess you do like we had out before, I guess. And just put them, no matter what, you do that here. Right. Right. The else is for the y. Because gx, no matter what, in these positions, you do -1. But for gy, you might do one or the other. Okay? Now, if we go to rho is equal to -1 or 1, and this time the column is equal to 1. So it's the two right positions, two right corners, right? We're going to, no matter what, gx is going to be multiplied by 1 and given back. So that's what happens right here. If rho is -1, though, we multiply gy by -1. And if rho else, we do it by 1. Perfect. Got it. Now, else if rho is equal to 0, meaning the middle row, for these two right positions in the middle row, if the column is -1, we multiply the gx by -2. Nothing happens to gy. It gets multiplied by 0. And if else, right, we're on the other side, we multiply by 2. Nothing happens to gy. Else if our column is now in the middle and we're doing these two positions, we are saying if the rho is -1, so this top one, we're going to multiply, nothing happens to gx, right? Because these are zeros, so the gy gets multiplied by 2. Sorry, this should be -2, -2, -2, and then this one should be 2 down here. Right, so if the rho is -1 for rho, column is 0, so this position here, we're multiplying the value by -2. Else, we're multiplying the value by 2. So that should... I think, does that look okay, you guys, for the most part? I mean, that was a lot of lines, so we definitely could have gone wrong somewhere, but it all kind of makes sense to me so far. What do you guys think? Hey, Insomniac, how you doing? Welcome. How's it going? How's your Sunday been? You just been hanging out, or what you been studying? How you doing? Okay. So that's what's happening here. So then, right at the end of this loop, at the end of all of this, we need to calculate that's at each move of the column, right? Okay, so this goes away. So the thing is do we need to count at any of these points? So here we go. Let's see. Now how we calculate, and before we were taking an average. Now we're going to figure out how to calculate and then what to assign back at those points using the g of x values, right? Okay, so in the g of x direction, for instance, we're multiplying the pixels to the right of the target pixel by a positive number and multiplying the pixels to the left of the target pixel by a negative number. When we take the sum, if the pixels on the right are a smaller color to the pixels on the left, the result will be close to 0. The numbers cancel out, but if the pixels on the left are very different from the pixels on the right and on the left, the resulting value will be very positive, very negative, resulting in a change in color that likely is the result of a boundary between objects. Using these kernels, we can generate a gx and gy value for the red, green, and blue channels for a pixel, but each channel can only take one value, not two. So we need some kind of way to combine gx and gy into a single value. The Sobel filter algorithm combines gx and gy into a filter value, final value by calculating the square root of gx squared plus gy squared. And since channel values can only take an integer values from 0 to 255, be sure the resulting value is rounded to the nearest integer and capped at 255. Channel values. Okay, so we then need to say, so we computed a GX red, GX green, GX blue, a GY red, a GY green, and a GY blue. We don't need to compute any count in this circumstance, but we are taking this is going to be GX red calc or total, GX blue total, and GX green total, right? We are going to take the GX red value for all of these. We'll say GX, we'll just say G red, G blue, G green value total is the round of the, let's go to, we have CS50X functions. Square root, calculate the square root, double square root x, so these are going to be doubles, these are going to be doubles, right? We round GX square root square root square root of, then do we have a square function? Okay, GX, we can do multiply by, right? Plus GY squared. Like that. That closes. That closes. That closes. And then one more for the round, like that. So we'll copy this guy for these. And change these to blue, green, blue, 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 green, almost there, green, green. If I were doing this, I would put the RGB values in a struct and overload the operator. Interesting. Yeah, I'm not sure how to do that. Okay, so we're not increasing count at all. And then we're not increasing count. Okay, cool. And then this would be image G red total, G blue total, G green total. Somebody teaching about Control D to select the same value set of 5 multiple times, edit all at once. Yeah, I don't have all the shortcuts down. I do a lot of stuff by hand still. Okay, right? So, is that it? Or whoa. Oh, I was editing my blur function this entire time? Ooh, that's okay. I was editing my blur this entire time. Let's go back here, I guess. Take this out of here. Whoops. Put this right here. There we go. And then we'll go back into filter less and take my blur and put it back into here. Whoops. Like that. Okay. Hey, Von Trail, question. We'll be learning DSA soon and saw you learning it in C++. However, you and I are both learning Python. Is it recommended to learn it in C++? If so, how do you reel it back to Python? Yeah, Von Trail. So, this is C. I'm not learning C++ right now. This is just C. Um, and the data structures and part of it is kind of just a part of the CS50X course that we're taking live on the channel. So if you're wanting to take that with me, then feel free, go ahead. I highly, highly recommend you take it with me. That we're actually working on the course right now. This is one of the problems for the problem set. But we mainly have been reading and doing data structure work in Python through the data structures and algorithms in Python book here. So I have this book in my Discord that we've also been just reading live on stream and working on these practice problems. So this is how I've been kind of relating it into Python. And then in this course, it's really helped to kind of solidify that information because, Python stems from C. And so, I can see where the connections are being made from language to language. Okay, so is that it? Are we done? So at each condition, we're calculating a gy, and a gx. We are then computing the square of gx and gy for each of those colors, square root and rounding that value, and then we're giving a double back. But I think actually it'll be integer because we're rounding this. So I'm not sure. Let's try it. I think we're good to give it a try here. If we have any problems, we'll find out. Anybody have any suggestions or things that they think I have wrong here? Okay. Math.h. Okay. Okay, that worked. Wow. That was the first time I've had no syntax errors. Wow. That was unbelievable. Holy cow. That worked right off the jump with that compiled. That was the first time I've had no syntax errors. Now we'll see if this works. Oh, come on. No. Oh, this is for gray. Okay, so our grayscale works. Our grayscale works just fine. Um, dash. What is this called? Edges? What's the command for it? What's the command for this one? R reflect E for edges. Ooh, get out of here. Whoa, that looks pretty good to me. That looks pretty good. That doesn't look too bad. Let's go. Okay, but I think we have an error, right? We need to handle the 255 thing. We didn't handle that. So I don't think we're gonna pass. So, wow, dude, okay, hold on, you guys. That is actually crazy. I didn't test this out at all. This was just my first attempt, and that looks like we're on the right track. So holy crap. Yeah, dude, that's so that's so rewarding, you know? This is working. Like we're learning from this class. Like it's awesome. Like this is just working out right. Okay, so now we need to handle the 255 thing, right? So where does that come into play? Um, oh, this is awesome. This is so cool. Okay, hold on. Where are you? 255. Let me look it up. Okay, here we go. Channel values. So what part do I have to capped at 255? Okay, so this one has to be capped at 255. So we'll say if G red total greater than 255, G red total is equal to 255. And then we'll copy this for all of those, basically. And say blue, blue. And then copy this one more time for here for green. And here for green. And now let's compile this. That looks pretty good. Ternary operator for the win. Yeah, we haven't learned about that operator yet. G red total equals G red total greater than 255 question mark. Oh, so you can like ask a question basically with the question mark. So is it greater than 225? If it is, set it right then and there in one line. Oh, that's really nice. Ternary operator. Yeah, we haven't learned about that in the course yet. Interesting. Thank you though for that suggestion. I'm sure we'll have to get there in the course and use that up. Okay, so we have this kind of weird border thing going on though. So I don't know if that is exactly correct. So maybe our rounding isn't going on exactly how it's supposed to be. So let's just see what the check 50 says and let's see. That's my goal. AI and machine learning. Just want to make sure I'm heading down the right path as learning this is time consuming. Want to make sure it's not necessary to learn C++. I often think that that's a lot of people's, mindset is that they kind of don't want to have like a sunk cost in all of this. They don't want to. Oh, yo! First try! First try! Woo! Yes! Round of applause. That's so awesome. Okay, cool. We get a celebratory nerds for that one. All right, you got to leave a like on the stream for that one. If you're here watching along, make sure you subscribe for that one. We completed the harder version of this week's problem first try. First try. Yes. No help, no nothing. I didn't look up one single thing. Wow. That's so awesome. I feel really, really good about that. Leave a like for that one, you guys. Wow, that was awesome. I had no syntax errors, right? All I had to do was include my header file for my square root function. No syntax errors on my first compile. And I passed check 50 first time. Wow, that's a first. That is crazy. Oh, that is actually so crazy. Feels so good. Thank you guys so much for being here with me and being here for this. Woo! Nice. Okay. That's so awesome. All right. Last problem of the week. Recover. All right, so this is recover here, you guys. In anticipation of this problem, we spent the past several days taking photos around campus, all of which were saved on a digital camera as JPEGs on a memory card. Unfortunately, we somehow deleted them all. Thankfully, in the computer world, deleted doesn't mean deleted so much as forgotten. Even though the camera insists the card is now blank, we're pretty sure that's not quite true. Indeed, we're hoping or expecting you can write a program that recovers the photos for us. In a file called recover.c, oh, this is really interesting. In a folder called recover, write a program to recover JPEGs from a memory card. For this program, you'll extend the functionality of code provided to you by CS50 staff. Okay. We'll CD back. Paste this in. Okay, we'll do this guy. We'll do remove recover.zip. Yes. CD recover. And we're in. Nice. Okay. Background. Even though JPEGs are more complicated than BMPs, JPEGs have signatures, patterns of bytes that can distinguish them from other file formats. Specifically, the first 3 bytes of JPEGs are 0xFF 255, 0xD8, and 0xFF. From first byte to third byte, left to right, the fourth byte, meanwhile, is either E0xE0, 0xE1, or 0xE2, all the way through EF. Put another way, the fourth byte's first 4 bits are always 1110. Odds are, if you find this pattern of 4 bytes on media known to store photos on a memory card, they demarcate the start of a JPEG. To be fair, you might encounter these patterns on some disk purely by chance, so data recovery isn't an exact science. Fortunately, digital cameras tend to store photographs contiguously on memory cards, whereby each photo is stored immediately after the previously taken one. According to the start of a JPEG, usually demarks the end of another. Accordingly, the start of a JPEG usually demarks the end of another. However, digital cameras often initialize cards with a FAT file system whose block size is 512 bytes B. The implication is that these cameras only write to those cards in units of 512 B. A photo that is 1 megabyte, 1,400 and 1,048,576b, thus takes up uh, 1,448,576 divided by 512 or equals 2,048 blocks on a memory card. But so does a photo that's, say, 1 byte smaller. The wasted space on the disk is called slack space. Forensic investigators often look at slack space for remnants of suspicious data. The implication of these details is that you, the investigator, can probably write a program that iterates over a copy on a memory card looking for JPEG signatures. Each time you find a signature, you can open a new file for writing and starting to fill that file with bytes from the memory card, closing the file once you encounter another signature. Moreover, rather than read my memory card's bytes one at a time, you can read 512 of them at a time into a buffer for efficiency's sake. Thanks to FAT, you can trust that JPEG signatures will be block aligned, that is, you only need to look for those signatures in a block's first 4 bytes. Realize, of course, though, that JPEGs can span contiguous blocks, otherwise, no JPEG can be larger than 512B, but the last byte of a JPEG might not fall at the very end of the block. Recall the possibility of slack space. But not to worry, because this memory card was brand new when I started snapping photos. Odds are it's been zeroed, filled with zeros by the manufacturer, in which case any slack space will be filled with zeros. It's okay if those trailing zeros end up in the JPEGs you recover, they should still be viewable. Now, I only have one memory card, but there are a lot of you, so I have gone ahead and created a forensic image of the card, storing its contents byte after byte in a file called card.raw, so that you don't waste time iterating over millions of zeros unnecessarily. I've only imaged the first few megabytes of the memory card, but you should ultimately find that the image contains 50 JPEGs. All right. Specification. Implement a program called Recover that recovers a JPEGs from a forensic image. Implement your program in a file called recover.c in a directory called recover. Your program should accept exactly one command line argument, the name of a forensic image from which to recover JPEGs. If your program is not executed with exactly one command line argument, it should remind the user of correct usage, and main should return 1. If the forensic image cannot be opened for reading, your program should inform the user as much, and main should return 1. The files you generate should be named hashtag dot 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 5, where the 3-digit decimal number starting with 000 for the first image and continuing up. Your program, if uses malloc, should not leak any memory. Interesting. Interesting. Thank you so much, Lo. Yeah, we cooked on that one. I felt really good about the last problem. You guys are awesome. On deployment and production environment, C++ helps. That's what I figured. I think my mind's ahead of my skill. My head is like, if I learn C++, but my coding in my app in Python, how would I use C++? Fairly new to this part. Yeah, Von Trell, like I was saying before we finished that problem, I don't like think of this time as like a cost. I guess it is a cost, right? But no matter what you do when like learning, when diving into programming, whether it be in C or in Python, you are going to be learning something, right? If it's something you obviously haven't seen before or experienced, you're going to be learning something. So, don't be caught up in like, I don't know which avenue or path to start. My advice is to just start, because the concepts, like, from language to language, all convey the same thing. It's just they're expressed in different ways. And so, just like with human languages, is in English versus Spanish, hello and hello mean the same thing. So, or hello and hola, right? It's the same thing. So I think it's kind of trivial and maybe a bigger waste of time to be worrying and having the anxiety about what avenue do I pick or where should I go, rather than just going down an avenue, and if it's not the avenue you wanting, then just going down a different one from there, right? There's no backtracking, because like once you learn something, you're not going to unlearn it to go relearn another thing. You're just going to take that material and apply it to a different avenue, right? And it'll line up somehow. Like, that's the beauty of it. So don't get caught up in the the individual, I don't know what to start, I don't know where to start, but just actually start. Hey, could you, KU Sibi, sorry, butchered that one bad. Can you provide me your PDF copy of data structures? Yeah, I have a ongoing GitHub repo of my data structures, DSA, and Python notes, which I have upwards of 8 chapters so far of notes and materials that I have gone over. I have markdowns, pretty in depth and broken down notes from my understanding of these chapters, as well as upwards of 10 to 15 to 20 practice problems for each chapter that we've completed live on the channel. So can be found in my description in the link in my GitHub, or you can also go to my Discord and get everything there as well. So everything is in those links below. Um, hey, Hardcoreism, welcome back. How you doing? Awesome for you to join me. You're great. Welcome back. Thanks, Michael. That's my line of thinking for everything, but for some reason not this. Yeah, I had that thinking too. No, don't be discouraged. I thought that same way at the start too. I bought my laptop January 1st, literally January 1st, 2024. I bought it at the big brand new. I had it delivered right then and there at the new year to make sure like okay, I'm starting the new year, committing last year to learning to code, and I actually didn't start until May, June time with Harvard CS50P, like I explained. And that entire 5 month, 6 month stint was me going through this process of being like, oh, I'm not really sure where to start. I was going down form after form after form, listening to other people's opinions rather than just generating opinions of my own. And I wasted 6 months, fuddling about with where do I start rather than just going in and just doing it. So, oh, we got some cookies being delivered here.
They're a little hot, so
Okay. Ooh, here we go. Let's pull down the camera here so we can show these off. Wow. Are these made with eggs this time and flour?
Yeah, they're
Last time she made eggs, made cookies, no eggs, no flour.
There's an egg shortage. We
Egg
couldn't
shortage.
get eggs.
These look pretty good. They look hot though.
They are hot. You can wait. I don't need to be here for the reaction.
I thought, yeah, you do. You love the reaction.
I know, but they're hot. I just couldn't wait to bring them in.
Well, can I have them in like 2 minutes?
Just leave them in there.
Okay.
And give me a yell when you...
Okay, I'll try them in just a second.
Come on. Yeah, it should be ready.
There you go. At delivery. All right. Yeah, so like that 5 months or whatever that I spent stalling between actually starting, I I just I wasted that time just messing around trying to figure it out when I could have been 6 months further along the road here. So looking back, everything's in hindsight, and we learn from that going forward. But learn from my mistake here, that mistake. I'll understand your NVIDIA example once I get into DSA, but I understand your broader point. Awesome. We'll have to try that when they cool down here. All right, so we're on recover.c here. Okay, so recover.c. Oh boy, we have to start from scratch here? Come on, don't do me like this. I was so used to all of the code given to us. No. Okay, so your program should, in a file called, accept one command line argument, the name of the forensic image from which to discover JPEGs. If your program is not executed with exactly one command line argument, it should remind the user of the correct usage. Okay, so, oh gosh, we got to do this ourselves now? This is going to be rough. So let's put, oh no, we want to move recover outside here. Let's go to the filter list. Let's go to filter.c and let's see this. So we char filters. Oh boy. I just ordered a 4080 Super PC as well. MacBook has literally low storage. Yeah. That's awesome. What kind of PC did you pick up, Insomniac? Sounds exciting. Okay, so in this program we do char star C. So char filter get opt. So get opt is what again? Get opt. What is get opt? Function in Python's opt. In C. And get opt in RC. Okay, so we need to recover here. So we need to one command line argument, the name of the forensic image. So okay, so if argc greater than 2, right? We're going to do this. We have an example visual. F do command required. Okay. So 2 command line arguments required, and we're going to return 1. Or we'll say dot slash recover right, and file dot jpeg, like so. So then we need it to go, so that's that. So if args they count is greater than 2, so then we need to iterate over the arg count, open, so arg, so char star file is equal to, or no, it would be file is equal to arg v index 1, right? We'll say f open a file. Okay, so we're going to open the file path name, const char path name, const char mode. So we're going to open file image equals this. We're going to open up image, and then the mode is going to be in read mode. So this actually going to be char star there, which is a pointer to that location. We want to open up image in read mode. Right? We have a pointer to image. If argc does not equal 2, that's a good. So we'll say if argv does not equal 2, to do that, right? And return 1. Char star image argv1. F open the pointer to get access to the data of the image in read mode. So what do? They do char in file opt in. So the F open in file is R with file. They say if it's null, could not be open, so we need that check. So if, oh, they use the F open here for the file here. Input image equals here. We'll put a string, image string, right there. Image string. If input image is equal to null, printf. What did they say in the filter? They say could not be opened %s for string in file. Could not open %s dot \n. And then outside of it, we have the input image, like so. And then return 4. They return 4 here, so 4, whatever. Image is already a pointer. Ampersand image will give you the memory address of the pointer itself. Oh, okay. Open the pointer at that location. So you call char star on that. You do another pointer on the input. So this is a pointer as well. And then you remove that. Okay, cool. So if the arg count is not equal to 2, we return 1 and print out this error, right? If we get this, if we pass this, we save the string char star pointer of the image string in argv index 1. We then call a file pointer to the open of that location in read mode. If there is an input image is equal to null, right, we could not open, return that. So now what? All right, let's go ahead and try these. Hey, Gina, we're going to try these cookies if you want to join. She's going to come in here. Let's try them. That's really good. I'll have to let her know. That is really good. Really good. Okay. So what's our next goal here? If the forensic image cannot be opened, so we should return 1. Files you generate should be each named. Everybody's throwing cookie emojis at me. Okay. So what's our next goal here, right? Do we... So they say... How can we... I don't know, how can we manipulate this image now? Open the memory card. Well, there's still data left. I mean, okay, so we'll say fread, right? Because we did this before in the volume file. We did this. We read we did while buffer while so we need to read until we encounter one of the keys, right? Open card.raw. Okay. Okay, so file.raw. that. For an F read, so we need to say while F read there we go. Okay, so PTR is the address of the first byte in memory in which to read data. So we need to do the address input image volume. We did header size 1 and input file stream. So we want to read onto our buffer. So we need a buffer here. So this is going to be our volume. What do we do? We said buffer is of that size, 16. So what is our buffer size here? $512 slack space. So what do we need to do here, you guys? Like, we're taking our buffer, forensic image of the cards. Yeah, so argc return 1. Gotcha, perfect. Well, awesome. Yeah, we did that perfect, right, too. Input image string. Okay, so this is the part where I don't know stuff. So we have file card. It's this. Open up the image in read mode on here. Okay, so then we say uint 8 underscore t. So the bit size, right, for the type buffer of 512 size, right, according to this guy here. Remember they said 512 was our buffer size, our byte size here. So that's how much it is going to be per buffer as we read per byte by byte. Yeah, right? So we'll say while fread input image, which is the file opened, so from volume, right, it's going to be a pointer to that location buffer. So actually this is going to be buffer here, a pointer to it. From our volume, see we had size of int16. Unassigned integer. Yeah, so then you say well, actually, we already know our buffer is 512, so we can just say 512 here. We want to output onto, we're going to read it from the input image, right? So the thing is, there's four things. There's a size in bytes of which type of data to be read, and then there's which is the number of those types to be read at once. So we want to read 1 byte at a time 512 times. Right? So that's what that says even here too, right? It says read 1 512 on the card until it equals 512. Not to 0, right? Equals 512 here. So we create an unassigned integer 8-bit type with a buffer size of 512 bytes. For a total of 64 bytes. 512 bits, 64 bytes. Okay. Oh, but they're not accessing the memory location at buffer. It doesn't look like. So now we need to create JPEGs. So we'll need to say f open so we'll need to have a so we need to create JPEGs from the data. The way you should use fread return 0 is literally false when your loop ends. Finally, until you The program should number the files it outputs by naming each ###.jpg where befriend sprint f and note this printf stores a formatted string in f sprint f. This function prints a formatted string to a memory and location memory specs it as input the address of a buffer, which must be large enough to fit the string, including its null character, a format string that specifies what to print and 0 or more subsequent arguments. The format string can optionally contain conversion specifications, placeholders that begin with percentage. So sprint f buffer. This is CS50 integer I. To print an actual percent sign, use %%. Caveats. Attributes. So we want to create JPEGs First, consider how to read card.raw all the way through. Recall that read data file. You need to temporarily store the data in a buffer, and recall further that the card.raw stores data in blocks of 512 bytes. As such, you're likely going to create a buffer of 512 bytes to store blocks of data as you read them sequentially. One way to do this is use the uint8 type, standard int, 8 bits, 1 byte. This type is called, since it stores an unsigned positive non-negative integer that requires 8 bits of space, 1 byte. Probably not the best idea though. You use 512 as a magic number here. Odds are you can improve the design further. In case it should return either 512 or 0, given the card raw contains the same number of. Now consider how to read data from memory card. Per its manual page, fread returns a number of bytes that it has read, in which case it should either return 512 or 0, given that card.raw contains the same number of 512 byte blocks. In order to read every block from card.raw, it should suffice it like this. Yeah. Keep in mind you should, format string allocation. Given the prescribed format, how many bytes should you allocate for that string? Check whether the JPEG spit out is correct. So we have while fread buffer 1 512 image equals 512, we're going to open wait, I went to output. Okay, so how do you need to do this? I'm stuck here. So we need to open some sort of output file and write it onto that file. But we need to do that at each iteration of the while loop. So we need to open, so we'll have a count, int, count is equal to 0. We're going to open, when we get a file, we're going to increase the count, right? And then we're going to open we need a string name. Open an example of the fopen. File examples.txt in read mode. So how can I dynamically increase the so we open let's just try to open a file, I guess. Test.jpg in quote read mode in write mode. We need to save this as file, as output. This will then say will fopen create a missing file. Okay, in write mode. Okay. We then say if file, if output equals null, print f failed to open file. Right? Like so. And then return 1. Okay? So that opens the print, that test.jpg. And we're going to write fwrite we're going to write the address of which to write. So my volume we wrote onto the address of buffer. I'm going to write onto int size equals 512. Put size in here. Put by count. This is going to equal 1 at first. Okay, so we want to write onto the location in memory of the buffer. We want to write a size of 512. They say size is 16, 1. We want to write from so we want to write from the buffer so what do? We read the buffer, we take the buffer, we write from the buffer onto the output. So we write from the buffer onto the output file, and then we call, no, let me if close. So we are. Anybody got any tips for me here? I kind of feel like I'm punching air here. Keep in mind your program should number the files, naming each where. So we check the command line arguments. We save the second command line argument as the input file. Right. Open the input file in read mode. If input equals null. Print cannot open input. File name. This input file. Input file equals null. Print that. We declare a size of integers 512. Buffer size is sized by count. Count starts as 1. Like so. We then say, while we read, because that will continue openly file test.jpg. If output file equals null, open the output file in write mode. Write the buffer onto the output, increase the count. I mean, let's try it. Don't think it'll work here, but do you have a check for the JPEG integer after reading 512 byte chunk? No, I that's what I don't really understand. Is what else do we need here? I'm not really following. Sprintf. Sprintf in C formats data and stores it in a string character inside of it instead of printing it to the console. So char buffer is 50, int number is 42, float pi is for buffer number, and d pi. So we can save a print, basically. Print direct console output. Ensure the buffer is large enough to hold formatted string. Make Cooper. Undefined input. Format char typo. Format specifies type char star, but the argument has type file star. Expected after the expression. Expected after the expression in line 24. A semicolon after. What's a semicolon here? What? 8. Expected after expression. And a variable name? Isn't that not just buffer? Expected semicolon after expression uint 8 underscore t. What is going on here? That's 512. That doesn't. How are we doing it? No. Okay. Okay. Okay, so now what's going on here? So we need to open at each instance So, I don't get this whole part about card and read mode. Your file should generate names where. So we need to open. This will be count.jpg. How can I insert make file naming dynamic? You can use printf to file name is 20. So sprintf so the sprintf generates So we need to generate a file name after on each open. So we open the output file here. So we need to do a sprintf. So a sprintf, which takes in a variable called file name. It formats a string and stores it in file name, ensures that the zero is padded. 0, 0. What if I don't want to store it in an array? So the sprintf will store it in a location. Count to 0. I kind of want to save this one for tomorrow. I'm kind of tired here, but we didn't get very far on it. we obviously need to have a count. We'll save. Awesome, Wicked. Working on a social media project in PHP. That sounds really awesome, dude. So you can do F open. You can do count plus dot JPG. Quote here, like that. Increase the count. Open up the next one. So now if we run this, Really? Well, they want you to open a file once you find a JPEG signature, not every 512 bytes. They want you to open a file only once they find a JPEG signature. So what if I just save my buffer as 512? Dynamic count. I don't really know. I kind of want to watch this thing here.
Whole bunch of these 512 byte blocks, then what you can do is start at the first block of the JPEG file and check to see if you found a JPEG header or not. If you haven't found a JPEG header, you'll keep moving on, looking one block at a time. Distinct header, meaning the first byte of every JPEG. In Recover, we've taken a memory card from a camera and accidentally deleted all of the images. Your task is going to be to write a program to recover those images, generating new JPEG files for each. How are you going to do that? Well, first, you're going to want to open the memory card file that we'll give to you. Then, you're going to look through that memory card file for the beginning of a JPEG file. Once you find a JPEG file, you're going to open a new JPEG file that you're going to start writing to, and you're going to keep writing data in 512 byte chunks until you find a new JPEG file, at which point you can close the old one and start writing the new one. And you're going to repeat this process, looking for new JPEG files, writing new data to those JPEG files until you reach the end of the file. How are you going to do all of that? Well, let's start by talking about how you're going to open the memory card file. To do this, you can take advantage of the fopen function, which will take as its first parameter the name of a file you want to open, and the second parameter represents what mode you want to open it in, where R stands for read mode, where you want to read information from that file. As you're reading that file, though, you're going to want to be on the lookout for JPEGs. How are you going to know that an image is a JPEG? Well, every JPEG begins with a distinct header, meaning the first byte of every JPEG file is OXFF in hexadecimal. The second byte is always OXD8. The third byte is always OXFF. And the fourth byte could vary a little bit, but it's always OXE0 or OXE1 or OXE2, anything that starts with OXE and then something. So it could be OXEF, for example. These are all valid JPEG headers. So if you notice this pattern of 4 bytes at the beginning of any 512-byte block, you can pretty safely assume it's the beginning of a JPEG file. So let's talk in a little bit more detail about JPEGs. Each JPEG is going to start with a distinct header, where the first 3 bytes, as we've talked about, are OXFF, OXD8, and OXFF. And the last byte is OXE0 or OXE1 or OXE2, anything up to OXEF. So this is the header that you're going to be looking for. And we'll tell you that each of the JPEGs are stored back to back in the memory card. After one JPEG ends, the next one begins, and so on and so forth, up through the end of the file, inside of these 512-byte blocks. So what does this mean for how you can...
Okay, so we are reading the buffer 1 byte at a time for 512 bytes. Total bytes. Right. So then, what does this line really tell us? The line tells us to read chunks of 512 bytes from the input file and process them. Buffer points to an array or buffer where data read from the file will be stored. The size of each item to be read in bytes. In this case, you're reading 1 byte at a time. The number of bytes to be read is 512 bytes. Return value. Fread returns a number of items successfully read. If it reads 512 bytes, it returns 512. If fewer than 512 bytes are read at the end of the file, it returns a smaller number, which might be 0 if the end of the file is reached in an error. The while loop will continue as long as fread returns 512, meaning it successfully read a file. Okay. So if buffer index 1 wait, hold on. Yeah, if buffer index 0 is equal to quote 0xFF close quote. Now, is it a string? That's what I... So we'll read the first chunk into buffer, the first byte, out of 512. If buffer index 0 is equal to FF, continue. Not a string, just like this. right? If buffer is 0, understands hexadecimal, okay. If buffer is equal to 0xFF, right, we want to open the output file at count.jpg. So if I take this, put this here, I don't think it likes this. Is incorrect. We're trying to concatenate integer. Just print f. Correct approach. So we'll have 50 JPEGs. So we'll go like this. We'll say string names. No, sorry. Int names is equal to 0. If we found a name, or if we found a count, we'll say count is equal to 0. Rather, if we found a buffer, we're going to increase the count. I mean, if we found a JPEG header, we're going to increase the count. Check the first 3 bytes. So if but hold on. Is it going to only read the first byte via this question and then do that check? Or it's going to read 512 one at a time? What exactly is going on here? I don't know. If you're the red. Okay, so if buffer this and buffer index 1 is equal to 0x d8, and buffer equals buffer index 2 equal to 0xFF, right? We'll increase the count. Okay, then we'll need to do a check on the last byte. So we'll say for int I equals 0, I less than 10. No. I can go all the way through A, B, C, D, E, or F too. So how can we iterate and check for a JPEG header? No, I don't want to look that up. It'll tell me the answer too quickly. So, right, we can loop our last byte, our fourth byte is either between 0, 1, all the way to 15 with F. So I will be 16 in this case. Right. So how can we check buffers? How can we check the byte when it goes from 9 to A, B, C, D, E, F? ASCII? That's E, F. Okay, so you can do a direct range between that. Okay, so C knows then you can detect ranges of those values. So like you say if buffer index 3 is less than or equal to 0x E0, and if it's greater than or equal to that, and buffer index 3 is less than or equal to 0x EF, hexadecimal is just one other way of writing a number. Okay, I didn't know how to handle that. So now that it's its own, it's the same as dealing with numbers. You can do comparisons on it then. So if it's within this bound, right, we know we're at a valid JPEG. So we're going to increase the count that we found one. We're going to open the output file. We're going to open the output file of count.jpg. So I didn't like that last time. So it said that open up the file name. So I don't want to. I don't want to hold them in an array. You can use a sprintf directly within the f open call. However, you need to really buffer to format the file name. What? What if I don't know how many files I am going to open? There's a verbal like count, yeah. So we want to open the file in write mode. I don't get this sprint F thing. We'll say open the first file name. You do need to save it though. Okay, so we'll say all right, count gets increased. I don't know this F sprint thing. So if I go char star file names is going to be, there's going to be 50 of them. Right? Chat's dead tonight, Slow. It's just you and me here, my friend. I appreciate you being here, Slow, and commenting. You're awesome. Okay. We got file name. Char file name. %D is a what? So we take file name here, increase the count by 1, say sprint F file names %D dot .jpg count. Awesome, Richard. Which CS50 are you taking? Are you taking this one that I'm currently on? Yeah, only do the free one. Don't pay for it. It's not worth it. There's no difference. So, file names is 50. Char. We increase the count. Sprint F into file names. Open the output file. file names in write mode. Converts the integer count to a string and appends JPEG to it, storing the result in a file name array. Do you not have to index into file name to set the specific one at each iteration? You're right to ask about indexing when dealing with arrays, but in this case, file name is being reused at each iteration as storing the new formatted file name. Oh, we're creating a file name of size 20 array. We are then increasing the count, saving in file name that based on the count, and then overwriting it again. File name is overridden at each iteration with a new formatted string using sprintf. You don't manually index into file name to change the specific character. So then we need to put the file name outside or inside of my loop, I'm sorry, so that this will get generated newly at each iteration. Okay. Right. Yeah, I didn't know about sprintf before. I never had heard. So what sprintf does is we create a buffer basically of a certain byte size. Sprintf will save that formatted string in there, and then we can override it each time, accessing the file name char. Right. So then we open that one already. If output, right there. And then we write onto the output what was on the buffer. We write like that, right? I believe. Right? So that now the only thing is writing here, we write at from the location of address and buffer onto the output file. $512. Let me see this. So the line is well expects the address of the data to be written and yeah, this is unnecessary, sorry. It is incorrect because fwrite expects the address of the data to be written and not the address of an array. So then we need to F close output. And then at the end of the while loop, close the input. Like so. Okay, let's try this. Okay, I got all 50 of them. Do we get it? Did we get it here? I don't know. Let's find out. This one's a little bit more tricky. I haven't had to use a lot of file opening and closing in C before, so this one did have a lot of learning curves here. But I don't think we got it. I don't know. Okay. Oh, because the naming, right? Why can't we view them? Yeah, I'm not sure why. Yeah, I don't know. Have you guys, did anyone else that solved this, were they able to view these images? Okay, so now we just need to change the naming format. So to clear out the stuff, so we need to remove .jpg. Yes. rm-f.jpg. Okay, cool. So now we just need to change the naming convention here to char star so then how could you front of the .jpg. You think I'm closing the file too early? So we'll go exit here. Do you want to write? You want me to close at the end here? Close output there? Well, we need to close the output after we write. We need to close every output file, right? Because if I were to do this one, output, yeah, see, output has to be closed where it's called in here, output. You only close once you encounter another JPEG signature. Right, you would close this file and then so we could say %D 03 here .jpg on count on just a buffer. I think that's it right there. Ooh, whoops. All right, let's go there. This is 16. No, it's not working still. Looks like your closes have to be one step behind your JPEG signature. So you'll say, so you encounter a signature, set a flag, and then when you encounter another signature, you close the previous file. So we'll say found bool found equals false, right? Like this. If found to true, if found is equal to true, if close but my output, it's not going to do it because my output's down here when I declare it. So that won't work actually. So maybe we need to close here. it's within the scope of this guy, of those, so I have to, I'm not going to get it there either. It's got to be here. Alright, I'll do this for just a couple more minutes and then I'm gonna head out here because I've got to spend some more time here. So, and writing the file code is directly in the while loop. I'll open. You understand, but you should be writing the file the whole time after that too. Yeah, you're right. So we open the file. File name in read mode. No. So we should say that file output is equal to null here. Right. There's like a flag. So then we say here, if output does not equal to 0 or null, sorry, right? Right, then we say f close the output here. Right, and then we increase count. So then we say return 1, close that off. Back to here, we say if output not equal to null, right, we will write here the buffer 512.1 output like so, and then we need to add once you encounter another signature, you just set it to null immediately as a flag like you were saying. If you encounter another signature, if it's null, not null, you close right then and there. If output is not null here, you write alright. And then another one here. If output not equal null, you're thinking once we f close file. No, output file, sorry. output, and then we return 0 here as we finished it. Because then on the output, just like that. Woo! Right, so you set the flag here for its output is null. If you properly detect a header and the output is no longer null, you close the output. You close the output. You set up a file name temporary buffer char that gets reset each time on sprint f. You open the output file to override that output. Right? If after this check, if there was no output check, you just write right then and there. If it doesn't equal null, meaning you found stuff, you write. And then if it does not equal null here, out at the end of the loop, you close the output and you close the input file. So if output does not equal null, you close the output, the previous output, right? Because you found a new one, you have to close the previous. And then you override output with a new creation of this file name. Right? Because you found one, you write that file onto output, and then you close it. I mean, you probably could have put the close right here. That probably would have worked too. Like that. Oh, so we still have stuff free open. So that's why we did it there and closed. We write, continue the loop, and close here. Nice. Yeah, you can, I didn't know any of this stuff that you could, recover JPEG files with a single loop like that. Yeah, exactly. All right, cool, you guys. So this was, I think this will pass check 50 now. Oh, no, not submit 50. Whoops. No. Check 50. There we go. All right, cool. So this was the recover.c. This one was a little bit more tricky than the past one, in my opinion. This one, having us to do it from scratch required a little bit more thinking rather than using the pre-existing code. Oh, no. Ah, shoot. Um, what's going wrong in this guy? Here is my code. I am not passing check 50, but I am seeing all 50 images. I think me too, yeah. What about if I swap these numbers? 1 by 12. What happens if I do that? Let's try that. I'm getting images. Let's check out this. Are your file names 0 indexed? No. Oh, good catch, good catch. So then we want to create the file name here, count plus plus. Make recover. Now we have 49 files. Cool. Check 50. Now we're starting off at 0, 0. Right, that was a good catch, Lo. I didn't check that. Come on. Come on. Yes! Woo! Good job, Lo. Thank you so much for catching that. Yeah, so the file names had to be 0 index rather than starting from 1. So all I had to do was just move my count from increasing above the sprint f to below the sprint f. Nice. Awesome. Woo! All right, you guys. This successfully marks right now, right here, the end of week 4, CS50X 2025 on memory. I will say there's a lot more on memory we need to learn. This was just scratching the surface with pointers and with things along those lines, but Like honestly, we didn't even use a malloc function this entire problem set. So in my opinion, that is kind of a bit of a problem. We haven't gotten any introduction to malloc at all, or practice with it. Actually, we saw it in the lecture, but we definitely need some practice with that and understanding, memory allocation ourselves and getting some fundamental practice with that. But it was good to do. I never knew that we could individually. I never knew how or what the process was of what it took to make filters on images and manipulate these pixels. And it was really cool and quite interesting to learn about here and actually perform. But the overall process was a little bit tricky of kind of figuring out these like buffer sizes and understanding these different byte versus bit sizings and stuff like that. But yeah, so I we had to in this problem we had to learn specifically that you can do comparisons, of greater than or less than or equal to on actual hexadecimal numbers, similar to they would at integers. And so I will say, we did have to prompt the AI for a little bit of help with this one, but for the most part, it was fairly it was okay. It did take us a little while to get though, just because it was starting completely from scratch to having to get 2 lines of user input on the command line arguments to checking those to declaring to allocating sizing or proper buffer sizing to reading files, checking over the headers of those files, performing the the output creation, and then writing to that output as well. So thank you guys so much for joining me this evening. I will be back tomorrow, just like usual, around 7 p.m. PST. Please join my Discord linked below, where I provide all of my roadmap for my learning and my studying. You can, access anything that you see on my screen, from the CS50X information to my notes on the other side of the screen over there. Whoa, over there. Yeah, you can access it all on there or on my GitHub. And you can also, talk to me offline, ask me any questions you might have. I know a lot of people are beginners that are struggling to, figure out where to start. And I kind of maybe have, created a path for you to go down if you're wanting to go down a similar route as myself. So thank you guys so much for joining me here. Let's just quickly submit 50 this guy, and then we can call it here. If you guys enjoyed this stream, we streamed for 3 hours and 30 minutes. So a good Saturday or Sunday stream here. Please give it a thumbs up. It really helps to keep YouTube, bringing in, new people into the channel and suggesting it. And also consider following along so we can continue to connect with subscribing. Our channel's been growing. This stream, we hit 1.2K subscribers. So super, super awesome. Let's check to see where we are ending the night off on. 1206. So awesome. We went up almost 10 subscribers alone just this stream. So really, really awesome. Thank you guys so much for joining me and, committing to not only, the stream and to the efforts of studying, but also committing to yourself. This is, a selfish thing that you guys are doing, and it should be a selfish thing where you guys are wanting to improve your own personal education in your own, own way. And we are doing this together. So thank you guys so much for joining me this evening. I'll see you guys tomorrow. And yeah, message me in the Discord so we can chat, and I'll talk to you guys later.